So here we go with the second starter. This time we've got a standard inclined plane, which is got friction. Mu is equal to 1/2, and we've got an object that's being pulled with a force of 100 newtons at an angle of 30 degrees to the plane. It's on the point of slipping up the plane, and we've been asked to find the mass of the object. So the key thing to pick up on here at the start is that it's on the point of slipping up the plane, and the plane is rough. Therefore, we've got to put a friction acting down the plane because it's about to slip up the plane. Then we should know that we're going to work perpendicular and parallel to the plane. So if we're going to work perpendicular and parallel to the plane, we want to break these forces down into their components. So here, next to the angle, we've got 100 cos of 30, and perpendicular to the angle, perpendicular to the plane and opposite the angle, we've got 100 sine of 30. That does say sine really. There we go, 100 sine 30. Okay, also in that direction, perpendicular to the plane, we've got a component of the weight. So that's going to be mg. This angle is also 30, so mg cos of 30. And opposite the angle, but down the plane here, we've got mg sine, as it's opposite the angle, 30 degrees. Okay, so now we can do the usual. Resolve. It's not applying to because it's static. There's no acceleration, so I'm going to resolve parallel to the plane, and we're going to get, well, which ones are acting parallel to the plane? We've got 100 cos 30, mg sine 30, and the friction. So we get 100 cos of 30 minus mg sine of 30 minus the friction equals 0, since in equilibrium. Now, we know that later on we're going to probably use friction equals mu r, so we can let the friction equal 100 cos of 30, we should know, is √3 over 2, minus mg sine of 30, we should know, is 1/2. So we've got 50 root, I don't know where that extra bit's come from, 50 √3 minus mg over 2 for the friction. Okay, next then, let's resolve perpendicular to the plane. Let's look back at our diagram, see what forces we've got in that direction. So perpendicular to the plane, we've got our mg cos 30, our 100 sine 30, and our normal reaction. So we get r plus 100 sine of 30 minus mg cos of 30, again is equal to 0, since there's no acceleration in that direction, it's in equilibrium. So r is equal to mg cos of 30, we should know, is √3 over 2, minus 100 sine of 30 is 1/2. So we've got mg √3 over 2 minus 50. Okay, so we're on the point of slipping. So friction is equal to mu r. So we're then going to substitute, where's it gone? We're going to substitute in from above. So we've got mu equals 1/2. We've got r coming from here. So we've got mg root 3 over 2 minus the 50. And then we've got the friction coming from here. Which is 50 root 3 minus mg over 2. So the question says find m. So it looks like we've got to collect all the m's together and move everything else the other side in the usual way. Well, first of all, let's get it all on one line. So let's multiply through by 2. So we get 50 root 3. Oops, hang on, that's not multiplied by 2, is it? So that's going to be multiplied by 2. 100 root 3 minus mg is equal to mg root 3 over 2 minus 50. Multiply through by 2 again, so we get 200 root 3 minus 2mg equals mg root 3 minus 100. Collect the m's to one side, everything else to the other. 200 root 3 plus 100 equals mg root 3 plus 2mg. Take out the m, so we get root 3, g root 3 plus 2g. And then m is equal to 200 root 3 plus 100 all over g times root 3 plus 2. So if we tap that into a calculator, what are we going to get? 440 over g is root 3, 2. So that's going to be about 3.7, 370. So what do we say? 372, 344. So it's going to be about 1.3-ish, I would think. But you can tap it in a calculator to check. That's approx. Can't tap that in quickly enough to make it accurate, but you can check that.